In this video, we'll be talking about sampling distributions and the central limit theorem. So one really cool thing about sampling distributions is that they are guaranteed to be normal distributions. So in statistics, we typically work with random samples that are drawn from populations. We want to make inferences about the population, but we only have our sample to work with. If we compute a sample statistic, such as a mean, how confident can we be that this mean is accurate for the population and not just our sample? And how much uncertainty do we have? So consider a sample statistic, like a mean, can also have a sampling distribution as well. So if we draw many different samples from a population, each sample is different. So what's the distribution of the mean of those samples, and how dispersed are the sample means around the population mean? So how can a mean have a distribution? Imagine we have a population of 1 million people. And let's say we randomly sample 1,000 people from our population many times. And each time we take a sample, we compute the mean for that sample and we store it up. So now we have a bank of, let's say, 1,000 samples and 1,000 sample means, which will converge to a normal distribution. So why do we care? In practice, we rarely get to work with full populations, and we rely on random samples to learn and make generalizations about the world. We want to know if we can be confident in making generalizations and claims using these samples. So what if, by chance, I drew an unusual sample? What if there's some margin of error around my sample statistic? I want to know, how big is this margin of error? So to answer these questions, what we need is a sampling distribution, the shape of the distribution around a sample statistic, like the mean. So sampling something 1,000 different times is really inefficient, and as we all, I'm sure, know, research costs a lot of time and a lot of money. So what if we could figure out the distribution of the sample means without having to take 1,000 different samples and do all that work? So for example, if sample means are normally distributed, all we need to know is the mean sample mean over many samples, and the standard distribution of sample means over many samples. Then we can say something about which population means would be very unlikely given our sample. Finally, this brings us to the central limit theorem. The central limit theorem is as follows. Given a random variable, x, with a population mean, mu, and variance, as the size of random samples drawn from the population becomes larger, the distribution of the sample mean will converge to a normal distribution.